Good afternoon. I'm Daniel from the infrastructure platform team as well. I have a short talk. Basically, we have some time, so we decided to just do a very quick talk. So if you are new, you guys here, it's good. So it's a short one, like half an hour, and so I'll try to give it a go. It's a talk I gave at the Mesoscope in Seattle last year. So I apologize if some of you have seen it before, but most of you probably haven't. So, and it's good to have a few presentations in your laptop, or even better, in GitHub. So, you know, yeah. So I'll get going. So the idea is that we have been discussing a lot about microservices, and actually Thanos' excellent talk, you mentioned several like schedulers, task schedulers, and microservice schedulers like Nomad or Mesos. So my talk is a bit about that. So in Mesos in particular. So just a bit of context. So Schibsted, that you know a bit already a bit about us, but I'll just give very brief context to help you explain why we do the things we do. One of them is that the Schibsted Media Group is actually quite a large company. It's actually nearly 7,000 employees and nearly 2,000 engineers, so it's quite a big shop. And we are present in 31 countries, and gives challenges that are unique or at least a bit rare. And we actually, this is an updated figure, we have around 250 million users, more or less. And this is in total all over the world, and this creates the unique large-scale challenges that we have been discussing so far. So on having that many users across that many countries creates some unique challenges. And just some example of websites we have all over the world. So basically Schibsted, one of the few things we do is have marketplaces, such as Segunda Mano, Fotocasa, this is a Spanish site, but also Finn, which is a Swedish marketplace, and also Le Bon Coin, which is, I think, the third biggest website in France, below the two big guys. So it's quite popular. And it's basically marketplaces for people to exchange all sorts of things, from houses to clothing to shops, jobs, etc. So we have 31 of those, at least, more than that. And in total, 200 million users. So get a few unique challenges. Actually, this is we also have some newspapers across the world. This is a BG, which is one of them in Norway, and it shows a lot of ice and snow. And the idea is that we have to think global, so it means that we have global challenges, which I'll explain what it means. It's actually a real technical challenge to be global. It's not just some nice thing to put on slides. It actually creates its own unique set of problems. And actually, this is a map, slightly out of date, of the countries we have presence in. This means that we have to deploy services all across the dark blue sides of the map, which is a bit tricky if you want to do some cool stuff. So, and this is kind of an imaginary diagram. But it's basically saying, actually, imagine we have a number of sites, a number of data centers, both in the cloud or in premises. And we have to, for instance, a challenge, which is a simple one, which is deploy the same application in all those systems. I mean, data centers, locations, etc. So, and for example, as an application would be a system that does automatic security scans. So it scans all the applications, all the nodes you have in that data center to check for vulnerabilities. And that would be one example, but you have many. Logging agents, the applications and the microservices themselves, etc. So our use cases say, I want to deploy an application in all the data centers I have in the world, which there are quite a few of them, quite regions in Amazon speak. And they actually have, some of them are physical hardware, some of them are like virtual clouds, like Amazon. Some of them are Google Compute Platform, etc. So it's a big challenge. And also I want them to be able to talk to each other, as well as I need to discover data centers, which is quite a novel concept. which is when you say data center, you can say Amazon accounts. So when new people open new Amazon accounts, we need to discover and do something about it. So if I want an application to run on every single account, on every single data center, I want to discover when data centers or accounts are popping in and when they are being decommissioned, which is some of the things we do. So let's see what we can do about that problem. One of them is, what do we have to make it happen? To deploy application across multiple providers, data centers, and locations in the world. Well, we sure have some technology to help us, definitely. One of them would be a task scheduler, such as Mesos, which is an Apache project which I'm sure you're familiar with. Another one would be an actual scheduler on top of Mesos, which would be Marathon, to pick an example, which is a long-running task scheduler on top of Mesos. So if you guys are not familiar with it, it's basically a policy maker to run tasks that are designed to run for a long time on top of Mesos. So you say, run this app, and Marathon runs it on top of Mesos for you. And I'll explain a bit more about that later. We also have Docker or container technologies, which helps with some of the constraints to, for instance, work on premises, work on Google, or work on Amazon, or work on other providers, such as DigitalOcean. So container technology actually makes that happen. And Docker is a specific instance of that actually works. And as you know, and we've discussed at some length at the previous talks, including Antonio's excellent one, is we have Netflix OSS technologies, which we use in Schibsted as well, which kind of can help in some of those challenges. And I won't go into detail about them because they actually have been discussed already. What would be service discovery? In this case, Eureka, which is a Netflix service discovery platform. And actually, we will be using for this talk the version number 2, which is in release candidate mode now, as far as I know. Is it? Oh my God, okay. And in any case, we used it successfully for this proof of concept, and it works. So you could replace it with some other tool. And actually, it had multiple data center support, and it was quite partition friendly. And another things that we use for this problem, or to try to approach this problem, would be Hystrix, which is circuit breaker platform for making circuit breaking requests, etc. And Ribbon, which is client-side balancer, which already Antonio has touched upon briefly. And this, I encourage you to check them out if you don't know them, which are apart from the Netflix OSS stack, that quite good. And if we put all these technologies together, we're still missing something, which is how do we make it happen? So we run an application and we run it everywhere in the world in all these locations. With the technologies I had, it's not enough. And actually, there are some paths missing. And when we set out to try to approach this problem, we said, actually, let's extend what works. Let's not create a whole new Mesos scheduler from scratch or create a new system. Also, it actually was a good experience to say, can we make it formal? So, and I'll explain a bit more what it means to make it happen. So it's well defined. So the system we create, it's very well defined. And this I'll explain a bit more. Not make it a bunch of scripts that cannot do the job. Make it a bit more formal, with a more formal API. And also stealing a page from the Netflix OSS book, actually having applications that do the one thing very well. We don't want to extend them. We create a sidecar or a companion app or microservice that extends that behavior. And that's actually quite good as well. So instead of saying, it's a bit about the microservice approach, which is instead of extending a system that works well with more functionality, let's add separate companion applications or sidecars that do the things we need. And what we did was a POC open source project we call Triathlon to go with the marathon scheme, which is basically, it's a wrapper of marathon. So it's a companion application to run applications using Marathon. So you can tell Triathlon, run this app, and it will run it. It has the same API, more or less. Well, basically the same API. The API is kind of transparent, so you don't have to learn a new one. It mirrors the Marathon API. And it's basically a tiny little companion application that, and it also has a formal API, as I said before, that lets you distribute applications between different clusters. And clusters, I mean completely different locations and even different cloud providers. And I have a little video to demonstrate it, but it's what it does. So you say, I want to run a service that does network security scanning in every single location I have, but Triathlon will do that for you. And it does an interesting thing, which is it does leverage Eureka too, in this case, even if it's deprecated, to discover data centers, which is, we talked about application or instance service discovery, but in this case we did data center discovery, which is the same concept, it's just a bit more fancy. And also when a data center goes down or it's taken out of offline or decommissioned, it's just this is automatically deregistered. Okay? And I'll just explain how it works a bit. So the architecture is like that. So you have two different providers, two different cloud locations. Actually, one of them would be a cloud provider, and the other one would be, for instance, on-premises hardware location you have somewhere. You have a Mesos cluster on each to run your applications. And then you have, obviously, the application running, some containers, etc. And you have the task scheduler, which is Marathon, that will actually let you run tasks on it. You also have a container registry on top of that, so you have your containers there, your images. And you deploy a service discovery system. In this case, we did Eureka 2. And then Triathlon sits on top of it. It's actually an application that's running as well. And you can ask Triathlon to run application for you, and they will run on both data centers. And we did, in this case, set up an IPsec tunnel, so the communication was secure between the locations. And again, it's basically going to the building blocks and taking what's there and extending it a bit. So, and then we said, I want to run an application on an arbitrary number of physical locations and providers. So how we do that? Okay, let's take the Marathon API and see if there's something that works for us in this case. And we found something which is the Marathon constraints idea, which is this one. And this is basically comes from the documentation, and it's extended a bit, which is basically you can tell Marathon to say, I want to run an application in my cluster in a way that it's only running individually on every specific type of hardware. For instance, in the case of Unique, you can say, I want to run a single instance of this application on every type of hardware I have. So basically tags. So imagine I have 3 racks. So I can say, I tag the racks, so rack 1, 2, and 3. And I can tell Marathon, run this application, 1 instance per rack, and it will do it for you. It will identify the nodes that are sitting on each rack and run on 1 single instance of the application in each one of them, which is not, it's just kind of a way to do it. And it has some other policies, such as clustering applications together, or actually can evenly distribute tasks. So you have several zones or racks or whatever you want to call it. You can say, take 10 instances and distribute them evenly across these tagged nodes, which is you can use leveraging, for instance, Amazon tags, EC2 tags, or any kind of system you have. So we took that concept and we extended it with data center. So this is straight from the Marathon API, but saying, for instance, I want to deploy one single instance of my app, of my service, for every single data center I have to do, for instance, some kind of monitoring or policy, or you deploy the Chaos Monkey, etc. I can want to group by, which is I have 10 data centers, deploy 50 instances, and distribute it evenly between the 10 of them. And this is done through service discovery, so it discovers the data centers using Eureka, which means that I don't have to keep a list of the data centers I have, or the Amazon accounts. It's just that they automatically register to the service discovery system, and Triathlon finds out, and then it does the policy, which is good. And I'll show you briefly. I have a video, but the code I will give the link later, so it actually works. It takes a bit to set up, but it's running code, and you can trust me, it works. It's just the video is more convenient. So in this case, I will say, I want to deploy an application in 2 different locations. And what I do is I'll tell Triathlon, deploy this app, group it by between the 2 locations, and just do a group by the instances evenly between the 2 locations. And it will basically do that. It will take every single marathon that's discovered and deploy the applications there, the instances. I have a tiny little video here. Make it a bit bigger, and you should well, yes. So basically what we have is we have a cluster in Amazon on the left, and we have a cluster in Google Compute Platform of 2 Marathon, basically 2 Mesos clusters. And basically what we see here is that we're running the Eureka Service Discovery applications, as well as the Triathlon itself. Triathlon in itself is an application that runs in both locations. So then what it does is say, okay, I'll take the API, which is a JSON API, and say, I want to deploy this app, which is a container, sits in a container. I want 4 instances, because this is the deployment I want. And I want it to group by the data centers I have. So I have 2 in this case, but I could have more. And I will take those instances and distribute them evenly across the locations. And there's no list of data centers. This is automatically discovered. And I don't have to maintain the list. And if you have the many accounts and the amount of accounts and data centers we have, you don't want to keep a list, unless you're an accountant, and then you want it. But in our case, as engineers, we don't have to. So what I do is I take this JSON API and run this command. I want 4 instances evenly distributed across my data centers. Just do it. Make it happen. And it will just call it. So you do a post request to the API, to Triathlon. And basically what it does is it knows already that we have 2 providers. One is Google and the other is Amazon, and deploys the instances evenly. As you see, the one is being deployed, it actually was doing 2 instances in there and 2 instances in Amazon. So 2 in Google and 2 in Amazon, and which is basically distributing the 4 instances between the 2 locations. They had 4 data centers, it would do 1, 1, 1, 1. Okay? I don't know what the rules are if you have 3 data centers and 4 instances, probably random, see 2, 1, 1 or something like that. It's in the API, so we just check it out. And yeah, it does it. It's basically taking the same container. And again, stress the point that I'm not maintaining the list of Amazon accounts or Google accounts. They are discovered automatically. And yeah, it deploys it, which is fair enough. And now the instance on the left in Amazon is actually faster to run for some reason, to deploy. And also the Google one is also running. And then we can go and access the app. It's actually a demo app of Google Game of Thrones quotes. No spoilers that I know. And I'm not up to date, so no spoilers for me either. So And it works. And this is kind of the Amazon instance running, but you can trust me that the Google one is also running as well. And in this case, also you can leverage Marathon. So if instances die, Marathon will take, and Mesos will take care of, launching them again, etc. So, it's not that you're on your own. And the second demo, very quickly. Okay, I have time. So, and if they actually will have time for questions. So if I'm going too fast with something, we can go back to it. This is another demonstration, which is, imagine, and what I did was a more balanced thing, which is distribute the instances evenly across the two providers, Google and Amazon in this case, which is an example. It could be anywhere else that Apache Mesos runs on. That can also run containers, obviously. In this case, I say, I want to deploy a single instance on each location. Because imagine, again, going back to the example, which is some kind of auditing system, which is not critical. They have just one instance that kind of from time to time does some checks. But it's a common enough use case. And in this case, the scheme is pretty much the same, which is deploy this application. Don't care about the number of instances. Just do it on every single location we have, every single provider, every single Amazon account, etc. And if you have hardware on premises as well, fine. And it will basically already have this covered, all the locations, and just run all the instances. And this is the video again. But I will point the links to the source in GitHub, in Apache 2, open source license. So you can, if you are very interested, you can check out the actual code that's making this happen, which, there's not a lot of it, but yeah. So in this case, I have a bunch of scripts to call the API. And yeah, it's just some bash functions to deploy an application to Triathlon. So in this case, this is to highlight one important point. Maybe it wasn't clear, but as a deployer, as a basic operator, if you want, I don't know the locations of the accounts and data centers and providers. I just call Triathlon, and then it will just take care of it and deploy it to everywhere, which is in this variable here, $triathlon. So this is some functions to deploy the application called the API, which is here. And this is some high-level script which will run in a while, which is just deploy this app, etc. And we will try to say, deploy 4 instances. But we are doing the unique constraint. So we actually want this to run one instance on every single data center or account. So the number of instances is not that important. It is not important, actually. And deploy this app. And this is the JSON payload for the Marathon API. And in this case, this is sent to Triathlon, which is, OK, deploy this app. You want to deploy it to unique locations. And here you go. So unique means one instance per location. And one only. And you specify the ports, memory, etc. And this is what we're doing. And yeah, it says, using the unique, we just run the bash scripts, and it deploys two instances in the 2 locations, which will do, and it just does it. In this case, Google was actually faster to deploy for maybe 1 second or something. And then you say, OK, kill them, which it does as well. And then you say, deploy 4 instances into data centers. But because we're using the unique constraint, it doesn't really care about the number of instances. It just deploy 1 instance per location. And yes, we can show it running again with some more quotes, but it's basically the app running as well. And this, again, is Amazon, but it also runs on the Google Compute platform. with no problems. And yeah, that's the quotes for you. And hopefully no spoilers. And again, we can kill them back, etc. I will just remove them from the two locations, the instances. Okay, exit. Okay, and this is all good, and videos are fine, and they are convenient to improvise talks. They're very convenient. So, because if you prepare it for the original talk, it runs then, but the second talk, it will not run. It will fail, dependencies will be failed to download or whatever. But in this case, the videos are convenient. So show me the code, which means that we have to code to prove that this is actually not a made-up video. And one of the things we released when we were preparing this is a project called Mesoscope, which is basically a Apache Mesos development environment. There are several other options to work on Mesos. This is one convenient way to do it. It's not the only one. Basically, it's one of the tools we use to do this kind of work, to try Apache Mesos stuff. And it basically uses Docker to run a Mesos environment locally. The other one is Triathlon. It's proof of concept code. Some people say that all code is proof of concept in this case, but it's real code. So everything I showed was Triathlon running, actually as applications, which is an important point. Triathlon itself was running on the actual clusters we saw. So it's not like a separate application that runs somewhere. And you could eventually use Triathlon to deploy Triathlon and do inception, which is quite a common theme. And yeah, it's in a nutshell, it's a global marathon wrapper that can deploy applications across several providers and clusters, etc. That leverages Eureka 2, which is deprecated, but it's reasonably abstracted from it, so you could use another service discovery mechanism, even Eureka 1 or whatever. And yeah, it works. So if you're curious, you can check it out. Some lessons we learned by doing this exercise, which again, is not just for fun. It's to say, the problem we have at the Schibsted scale, which is I have several cloud providers with several regions across several continents. I have quite a few data centers with physical hardware, and I have the need to deploy an application from a high-level perspective, to say, run it everywhere with this policy. And we built Triathlon to try out that concept, which is a thing we need. And one of the things we learned while we were doing it is we had this romantic idea of running a single Mesos cluster across providers and regions. It's a very romantic idea for Friday night, but definitely not for production. But it was fun to try it out for a bit. And actually, no, yeah, as I said. And the service discovery, in this case, was very availability and partition-friendly centric. So it doesn't have to be very consistent. Just make sure that you know the service, the data centers that you want to know. And we need more Eureka 2, and now I would say we need more partition-friendly service discovery mechanisms. We'll see about that. And containers are good, quote. But in this case, it shows that the magic of containers we take for granted now, which is the same image actually running on two completely different and competing providers. And it works. It kind of, we get used to it, but it looks magic from some perspective. And the final one would be prepared to read code. We had to read a lot of code to do this piece of work. And just briefly, some of the next steps we want, and I wanted to highlight the networking side of it. So for instance, using Docker or some kind of SDN technology, make sure that we have some network isolation, because this will create problems when using different providers, different IP ranges, etc. And security, just put it in the end, because you have to put security everywhere these days. And yes, we are also hiring, so, but this is a collection of some of the links. We'll be around later, so if anyone has further questions, or drop me an email. And actually, we have some time for questions, like 3 minutes or something. So one quick question, if not later. Yes?
A really cool project. I just wanted to ask you, did you guys do anything about intra-node security, like security groups or something in your Mesos cluster? Or how does like a service authenticate with other services on the network? Is it like, how do you do that? I saw like you mentioned IPsec, which is probably between data centers.
Yeah, so that's a very good question. Again, did we actually do any security between services, for instance? And if we also did it between locations? We did IPsec between locations as a quick and dirty way, but it actually proved quite good, to be fair, in this concept. Between services, it is a project we are working on. We don't have a solution with a capital S. We have some workarounds. But definitely not something, it's like we have a final say on it, if ever. On the other hand, what we have been working on recently is leveraging some SDN technology to make at least isolation between groups of services a reality. So you have like virtual networks that automatically generated that make at least isolation between different services that you don't want to see each other. That's not service identity, it's not that secure, but it's a bit more secure. It's just an open IP space that everybody sees each other.
Thanks.
Maybe, yeah? Up, throw it up. Do like that. Next time, you have to do like that, a blind throw. Like
this.
Yeah, exactly.
Thanks for the talk.
Yeah.
So how do you manage failure? Like imagine that you are trying to deploy to AWS and to Google Cloud, and one of the providers fails. What do you do? Is it rollbar? You try, or what do you do?
So that's a good, also very good question. I actually got the same question at Mesoscope, which is, it displays how it is also very relevant. We had discussions about security as well. In this case, we wanted not to be extremely consistent. We gave up, if you like, on extreme consistency. So imagine you say you deploy to several locations, and one of them actually doesn't work. This is the same, happens at the node level. So you can deploy several services, and one deployment can fail. So this at the single cluster, in a single cluster, you can manage it with a scheduler to say, a deployment has failed, let's do something about it. If you have a higher scale, pretending to have the same level of consistency is probably not a good idea. So what you want to do is, my system should still run, even though that data center is offline, or maybe it has a slightly different version. We should run, because this chaos engineering tells you that it should work, even in that situation. And then you have some kind of monitor. So I would say that in this case, it's better to take that pragmatic approach. And chaos engineering tells you that you should still be up, even if the deployment in a location fails. You should have a red flag somewhere, let's fix it. But if that data center is not reachable, then you already have a problem with that location. Then take it offline, the whole thing, and make sure that the ones that are reachable are okay, and then handle that problem offline, if you like. That's it. Are we on time? Okay, I'll be around for more questions later, so thanks for your time.